Hi, welcome to Learning Target 1.2. I can write a recursive formula and use it to find terms of a sequence. So a recursive formula is maybe not something that's really brand new to you. You might have seen it in the past using something like T of n and T of n plus 1 and used it to find the terms like the sixth number or the seventh number in the sequence. We're going to do something really similar to that today, but we're going to add on some new notation and some different letters and might get a little bit confusing. We're just going to put a little higher level formal math to it. So first thing we want is vocabulary. So at any point in this video where it's gone too fast, you can always rewind it, you can always stop it. So grab a piece of paper and a pencil, and here we are. Vocabulary. Sequence. What is a sequence? A sequence is just an ordered list of numbers. So it can be any numbers in any sequence, can have a pattern. It doesn't have to have a pattern. It's just an ordered list of numbers. If it's recursive, what that means is that one term is built off of another term. So in order to find the 10th number, you need to know the 9th number. So a recursive sequence is just that pattern of numbers where one number is found in relation to the previous term. So you can't just find the sixth number. In order to find the sixth number, you have to know the fifth number. In order to find the fifth number, you have to know the fourth number. So you have to know every number up until then. So today we're going to talk about recursive formulas. Recursive formulas, that's how we define the sequence. So you might know of a formula like 2x plus 1, and it kind of is the recipe or the method to follow in order to find the numbers that we want. So that's what we're looking for, and today we're going to write some of those recursive formulas in order to be able to define a list of numbers using letters so that we can have a pattern to follow to find any of the numbers in the sequence. So how can we get a recursive formula for the following sequence? We need two things. We need a starting point, and in this case that starting point is -5. And then we need a pattern. So how do we find out what that pattern is? That pattern is, how do I get from this number to this number? So if I take the first number, I want the second number. I want the second number, or I have the second number, I want the third number. The third number to the fourth number. What's the pattern? The pattern has to be the same for each of them. So if I don't see the pattern from -5 to 2, maybe I see it from 2 to 9. Oh yeah, I know 2 plus 7 is 9. I know 9 plus 7 is 16. I know -5 then plus 7 is 2. So that means when I'm looking for the pattern, I see the pattern is plus 7. So how have we written this in the past? We might have used something like T of n and T of n plus 1. So what we're going to do is we're going to use different notation. The different notation we're going to use is we're going to call it u sub 1. So instead of calling it T of 1, we're going to call it u sub 1. With that said, sometimes in math, we call it a sub 1. And if we use a sub 1, it means actually exactly the same thing. Some textbooks like a sub 1, some textbooks like u sub 1. It doesn't really make any difference because it means the exact same thing. And so we also could call it a sub n instead of u sub n. So u sub 1 is just the starting point. It just means what's that first number. So instead of writing T of 1, we're going to write it as u sub 1. And then u sub n, we're going to use this notation that's called u sub n minus 1. And then we're going to find the pattern, and we're going to either add, subtract, or multiply that pattern. So we have to look at what does this actually mean, this un and this un minus 1. And so if we wanted to find a number, the number 5, n minus 1 would be 5 minus 1, which would be 4. So it's just telling you this is the number and this is the number before it. And you're going to take that number and do this pattern to it. So let's look at how that works. If we're going to talk about this sequence, if I'm going to talk about this sequence, the first number is 3. So u sub 1 is 3. The second number is 7. So u sub 2 is 7. The third number is 11. So u sub 3 is 11. The fourth number is 15. So u sub 4 is 15. So if I look at this and I'm looking at, so what does u sub n mean? U sub n could be any term in the sequence. So u sub n is just a holding place, like an x or a y, that it's just that we don't know that number, we can substitute a number in. So if u sub n is any term, then what is u sub n? Well, or I'm sorry, what is u sub n minus 1? Well, if u sub n was 3, n minus 1, well, 3 minus 1 is 2. If u sub n, if n was 4, n minus 1 is 3. So u sub n minus 1 just means the term before u sub n. So this is how we're going to use the pattern to build recursively or build one number from the one before it. So in order to find u sub 12, what do we have to know? We have to know u sub 11. We have to know the number before it. And the reason why is because of the definition of a recursive sequence. We build a sequence on the previous term. So if we don't have the previous term, we can't build the sequence. So if u sub n is 15, then u sub n minus 1 is 14. Because if n is 15, n minus 1 is 14. If u sub n minus 1 is 51, this one's tricky, then u sub n would be 52. Because if n is 52, n minus 1 is 51. So if we're going to write a recursive formula, this is kind of the nuts and bolts of what we want to look at today. We're always going to start with u sub 1. U sub 1 is always going to be that first number. There's no thinking that goes into play for that. You're just going to write down that number. We're going to write down u sub 1, and you're going to write down that number. So then when we want to find the pattern is always going to start off with a u sub n, because we want to find any number, and we're always going to use that u sub n minus 1, because this is what it's saying is to find a number, take the number before it, and do something. So we have to figure out what that pattern is. What is that something? -6 up to 1, 1 up to 8, 8 up to 15, 15 up to 22. We have to figure out what that is. And if you can see it, that's awesome. Write it down. I see it. It's +7. If you don't see it, you could take any two numbers in the sequence and subtract them. Because if you want to find out what number adds to what number adds to it to get a certain number, the opposite of addition is subtraction. So if I take 22 minus 15, I'm going to get 7. If I take 1 minus -6, I'm going to get 7. So that means this recursive formula right here describes this pattern of numbers. So if I'm going to look at the next recursive sequence, I'm going to write the recursive formula. The first number, remember it's not anything to calculate, you just look at the number and it's 15. So then I have to figure out un is equal to, and I'm going to always have un minus 1. So to find any number in the sequence, I'm going to take the number before it and I have to figure out what that pattern is. So I'm not necessarily sure, but I see this is decreasing. This was increasing, so we added, so we can look at decreasing. Well, 15 minus what is 6? Or I can say 6 minus 15 is equal to -9. And you can find out between any of them because the pattern has to be the same in order for it to be a recursive sequence. So there we are. There is the recursive formula that would generate this recursive sequence. What that means is if I took -12 and -9, I'm going to get the next term. -9, I'll get the next term. -9, I'll get the next term. -9, I'll get the next term. It's the same pattern every time. Because they're arithmetic, I know I'm adding and subtracting. So when I look at geometric, I'm still starting off the same way. I'm still starting off with u sub 1 being equal to 10. That's the first number. There's no thinking, you just look. The next is the pattern, and I'm still going to start off with un, and I'm still going to have un minus 1, because that means I take the number and I do something to the number before it. So we have to figure out what that something is. And in this one, I can see this one, 10 to 30, 30 to 90. I know it's geometric, so I have to be multiplying. What am I multiplying by? Well, it's times 3. So I'm going to put the 3 in front of it, And the reason I'm going to do that is just because I like to see it that way. You could write un minus 1 times 3. I do this because when I'm writing in algebra, if I want to say 3 times something, I would write 3x. I wouldn't write x3. So I personally choose to put the 3 in front of it. I know other teachers, even in Fridley, will put times 3 at the back, and it really makes no difference. They're both correct. So let's look at the next one. U sub 1 is equal to nothing to think about. It's just that first number, 324. And then I have to look and say, what's the pattern? I'm going to put that pattern as un equals, and I'm going to have a un minus 1. So what happens here, your elementary school teachers told you, if you multiply, you always have to increase. But that's not always the case. Sometimes when we're multiplying, we do decrease, and the dirty little secret they don't tell you about is what kind of numbers we multiply to decrease. So I'm decreasing here, and I don't really know what's happening. If I'm looking at 324 and 108, I might not see that. 108 to 36, I might not see that. 36 to 12, I know that 36 divided by 3 is 12. I know that 12 divided by 3 is 4. So I know that I'm figuring something here with a factor of 3. But what I want to be doing is multiplying. I need to know the number to put right there. So I'm going to say 4 divided by 12. And if I reduce that fraction, I'm going to get 1/3. That number goes right here. They get tricky, and yes, you can put it as a decimal if you choose to. You can do that with any of them. 36 divided by 108 is still going to be 1/3. 108 divided by 324 is still going to be 1/3. So there is your recursive sequence. So that's the goal of today, is to be able to write a recursive sequence and then be able to find the terms, which is what we're going to be doing now. So if I wanted to find the terms, write the first 5 terms of the sequence. What I'm trying to look for here is 5 numbers. 1, 2, 3, 4, 5. It says the first 5 terms, so I'm starting off with u sub 1, and u sub 1 is 2. I know that because that's what it says right there. So now if I want to go and find the other ones, I'm going to actually take my calculator, and my pattern says times by 1.5. So I'm going to take my calculator, and I'm going to say 2 times 1.5, and the answer is 3. Times 1.5, and the answer is 4.5. Times 1.5, and the answer is 6.75. Times 1.5, and the answer is 10.125. And that's my first 5 numbers. So I'm going to write those in here. 2, 3, 4.5, 6.75, and 10.125. So, of course, in math, we always have to add our word problems in there. So a square table seats 4 people. 2 square tables put together seat 6 people. So I'm going to draw this out because I always like to make a picture of a word problem. So I'm seating 4 people. So that's my first number in my sequence is 4. And then it says 2 tables pushed together. So if I have 2 tables pushed together, it's going to look like this. And I can seat, it says I'm going to seat 6 people. So my sequence says 4, 6, and then I want to find 3 tables pushed together, seat 8 people. So if I wanted to ask you a question like, for example, how many people sit at 10 tables? What you're going to do is you're going to find the pattern and you're going to continue it out 10 times. So I want you to try to do that. The answer that you should get, the pattern is adding 2. And so the answer you should come up with